Code Explained says hi. Today we're going to create a 2D Breakout game using JavaScript. In this game we will show to the user how many lives he has left, the number of the level, and the score. And at the bottom here I have a button to turn on and off the sounds. When the user loses the game, we show the game over message and play again button to play again. I will try to turn off the sounds and try to win this game. To win the game you have to break all the breaks in each level, and this preview I set the number of the levels to just 3. Now each time you win a level or you go to the next level, we increment the speed of the ball and also increment the number of the breaks. Also, in our game, when the ball hit the puddle, it goes in a definite direction. So, for example, here it goes to the right, and here the ball will go to the left. And if the ball hit the center of our puddle, it will go in a vertical line. Now you can see or you can feel the speed of the ball. And when you finish the game, we will show this image to the user and the play again button. So let's go and create this game. Like always, we're not going directly to type in the code. We need first to understand the logic behind the game and then open our text editors. In general, to create games you will need somewhere to draw, which is the HTML canvas, and you will need somewhere something that will do the maths, the drawing or the logic, etc., which is JavaScript. Now in our HTML file we will create an element called canvas with the ID Breakout. The width it's 400 pixels and height of 500 pixels. This will create a rectangle with no border. Its width is 400 pixels and its height is 500 pixels. This is our canvas. In the JavaScript part, we will need first to select our canvas using getElementById method. Then set this to a constant called canvas. Then we will get the context of our canvas, which will return methods and properties that will give us the ability to do a lot of things on the canvas, like drawing. So instead of writing this whole line of code again and again, we will set this to a constant called context. To make our game, we will need to know how to draw a rectangle, draw a circle, an image, and to load or play the sounds. Now let's talk about drawing a rectangle. To draw a rectangle, we will say context.fillStyle. The fill style here is the rectangle's color, for example red. Then we will say context.fillRect. The fillRect is the method we will use to create or to draw a rectangle on the canvas. It will take in the X position of the rectangle, its Y position, its width, and the height. Before drawing something to our canvas, you will need first to know where is the X-axis and the Y-axis. This is the X-axis, so it's incrementing as we are going to the right, and this is the Y-axis, and it's incrementing as we are going to the bottom. Now if we say fillRect and we give the X the value 150 pixels, we will need to go and start from the left and then take 150 pixels. If we say y is 200 pixels, then we will start from the top and take 200 pixels, which means our rectangle will be drawn in this position. This is its width, which is 100 pixels, and this is its height, which is 50 pixels. So let's say we need to move a rectangle. First, we will need to draw our rectangle, for example, in this position. And then I will put this inside the function. The function will take in two parameters, the x and y position. To move this rectangle, for example, to the bottom, we need to change the y position. Right. To draw the first rectangle, we will need to run this line of code. Draw 150 for x and 200 pixels for the y position. Now to move our rectangle to the bottom by 50 pixels, you may think that we have just to say draw rect 150 pixels and increment the y position by 250 pixels. But the truth is that this line of code will just go and draw another rectangle in the new position, because for the computer these are two different rectangles. So to fix the problem, before drawing this rectangle in this new position, we need first to clear the canvas. To clear the canvas, we will use a method called clear, which takes in two parameters. This is the x and this is the y position from where we start the clearing. And then we will clear the canvas from the top left here corner to the canvas width, then to the canvas height. So using this code, we will clear the whole canvas. So this line of code will clear the canvas, which means take off the old rectangle. Then we will draw the new rectangle in the new position. Again, we will need to clear the canvas, then draw the rectangle in the new position, and so on. So as you can see here, we can put this inside the function as we are using the same line of codes again and again. So I will create a function called loop. So loop because we are going to call this function a lot of times. So inside I will clear the canvas first, then I will draw the rectangle, but as we are changing its y position, I will need to set this as a variable y. Then I will increment the y position each time by 50. Now at the end, I will use a function called request animation frame. This function here will call the loop function as long as your browser is ready to render the next frame. So what will happen here, when we call the loop function one time, we will go and run this line of code, then this one, then this one. And when we arrive to this line of code, the request animation frame will call the loop function again, which will create a loop. For our game, we will also need a loop function that we will call just one time. The request animation frame will keep calling the loop function every time your browser is ready to render the next frame. Then we have here a draw function. Inside the draw function, we will put every line of code that will help us to draw something to the canvas. Inside the update function, we will put the game logic. Also, we need to clear the canvas. For that, I will use an image instead of the clear method you saw before. So I'm gonna clear the canvas using an image. Here is the position of the image. So 0 for x and 0 for y, which means we will start drawing our image from the top left corner of our canvas. The draw image will also take in the image object. So if we call the loop function for the first time, you will get something like this. But before this, I need to load the image first. So I'm gonna go and create a constant called background image, then equals the new image object. Then to load the image, I will use the source property equal to the path of the background image. Now let's go and create our puddle. Our puddle here has a width of 100 pixels, 200 pixels for the height. This is its x position, this is its y position. So to handle this, I will create an object called paddle, which has these properties. Let's now define the x property. This is our canvas that width divided by 2, and this is the width of the paddle. So this is the width of the paddle divided by 2. Now the x is the canvas that width minus the width divided by 2. That's the x position of the paddle. For the y position, this is the y position, this is the height, and this is the margin bottom, which I have to define. So the margin bottom is 50 pixels. So I will say the canvas dot height minus the height of the paddle minus the margin bottom. This is the y position of our paddle, which is a constant. It won't change there in the game. Now for the width, the height, and the x, I will use 5. The x stands for delta x. This is the amount of pixels the paddle will move to the right or to the left. Now to access these properties, we will just need to say paddle.x, paddle.y, paddle.width, and height, and that the x. This is a fancy way of saying height of the paddle, the width of the paddle, and so on. Now let's go and draw the paddle. Drawing the paddle is easy. It's like drawing a rectangle. So I will need to set the color which with I will fill our rectangle. Then I will use the fillRect method, which takes in these parameters, the paddle.x and y position, its width and its height. You can see here that I have a stroke. To draw that stroke, I will need to set the stroke style, which is the color, and then the stroke rect, which will take in the same arguments as the fillRect. And I will put this inside a function called drawPaddle. This drawPaddle here function will go inside our draw function. Now let's move the paddle. The paddle will move either to the right, which means incrementing its x position, or to the left, which means decrementing its x position. To control the paddle, the user will use the right and the left arrows on the keyboard. So, to listen to the keyboard, we need to add an event listener to the document, which is in key down. Key down means that when the user presses a key on the keyboard, we will fire this function. And also we need an event listener, which is on key up, which means when the user releases a key, because we want to move the paddle as long as the user is pressing a key, but we want to stop when the user releases that key. So we will say f even the key code is equal to 37. Here 37 is the key code of our left arrow, and here we will say f the event.key code is 39, which is the key code of our right arrow. Before, we need to create two variables. The first is the left arrow, the second is the right arrow. I set them both to false. This means that the left arrow is not pressed, which means that set them to true means that the left arrow is pressed, for example. And also here I would say right arrow equals to true. And here on key up we need to do the opposite. So we'll say f event.key code is 37, we set left arrow to false because the key is released. Then f the event.key code as 39, we set the left or the right arrow to false. Now to move the paddle, we'll just say f right arrow as pressed as set to true. We will move the paddle to the right by delta x. And else if it's the left arrow was pressed, we will set or we will decrement the x position of the paddle by delta x. We have here a problem because, for example, let's say the user is moving the paddle to the right. When it reaches the right wall here, it will go beyond that wall. So we need to prevent that from happening. To prevent that, we will do just some maths. So this is the canvas.width, and this is the paddle.x. So this is the paddle.x plus the paddle.width. So this is the right side of our paddle. So we need to move the paddle as long as this value here is less than this value here. So I'm going to say and paddle.x plus paddle.width is less than the canvas.width. Also, we want to move the paddle to the left as long as this value here is greater than 0. So I'm going to say if left arrow and the paddle.x is greater than 0. Now I will put this inside a function called movePaddle. The movePaddle function will go inside our update function, not inside our draw function, because we are not drawing nothing here. Let's now talk about creating the ball. The ball must be in this position. This is the ball radius, which means I need to create a constant called ball radius. I'll set it to 8, for example. You have to know that there is a difference between a ball and a rectangle in which concern the x and y position. For the rectangle, the x and y position of the rectangle is the top left corner of the rectangle. The x and y position of a ball is its center. Now, for us, this is the x position and this is the y position of the ball. Now let's create our ball object. So for the x position, it's the canvas.width divided by 2. So easy. Now for the y position, this is our paddle.y. That remains constant. It doesn't change. So I will say y, position of the ball. It is the paddle.y minus the ball radius. Then this is the radius of the ball. This is the speed of the ball, which is I set to 3, for example. Then delta x and delta y is set to -3. We will talk about this soon. Now here's something you need to know. This is the y position, for example, of the ball. But the top of the ball has a position of y minus the radius of the ball. And for the bottom of the ball, it is y plus the radius of the ball. Also, this is the x position. The left side of the ball has a position which is x minus the radius of the ball. And here, the right side of the ball has a position which is x plus the radius of the ball. Now let's talk about drawing the ball. To draw a ball, we need to create a path. To do that, I will use the method beginPath, and then at the last I will need to close that path. Now our ball is a filled circle, so I will use the arc method, which takes in the ball.x and y position, the ball radius, then the start angle. So we will start from 0 angle, then the last or the end angle is the method pi times 2, which is 360 degrees, the angle of a circle. Now to draw this path, I will need to use the stroke method, and if I want, I can set a color to draw the stroke. And now we need to fill our circle, so I will use the fill method, and also I will need to set a fill style, which is this color. And last, I will put these lines of code inside the function drawBall. This function drawBall will go inside our draw function. Now let's talk about moving the ball. So this is, for example, the ball. If we are incrementing its y position, it means that the ball will go to the bottom. Instead, if we are decrementing the y position, the ball will go to the top. And if we are incrementing the x position, the ball will go to the right, and in this case, it will go to the left. Now, if we increment the x and y position, the ball will go in this direction, and if we are decrementing and incrementing the x position, the ball will go in this direction. And also if we are decrementing both the y and x position, the ball will go in this direction. The last one, the ball will go into this direction. So in general, to move our ball in this game, we will need to change both the x and y position. We will change the ball at x by delta x and the y position by delta y. I will need to put this inside the function moveBall, which will go inside our update function. If you remember, we already set the x to 3 and the y to -3, which is this case. So when the game starts, the ball will go in this direction because the x is positive, as you can see here, and the y is negative. So our ball will go in this direction when the game starts. Now, how can we detect if a collision happened between the ball and the wall? Let's say this is the ball. We set the y to -3, the x to 3, which means the ball will go into this direction. So when our ball reaches the right wall, it should go into this direction. This is our canvas that with it, right? And if you remember, the right side of the ball is x plus the radius of the ball. So there is a collision if this value here is greater than this value here. So I will say if the ball at x plus the ball at radius is greater than the canvas that with it. If the ball is going into this direction, it means that we are decrementing the x position and decrementing the y position. So if you can see here, the y position remains the same when the ball hit the right wall. What changes is the x position. So to do that, I will say the ball at the x equals minus the ball at the x. So simple. Now when the ball hit the top wall, it should go into this direction. The top of our canvas or y position is 0, and the top of our ball is the y minus the radius of the ball. So when this value here is greater than 0, means there is a collision. So I will need to say if the ball at y minus the ball at radius is less than 0. If the ball is going into this direction, it means that we are decrementing the x position and incrementing the y position. Again, you can see here that the x position still has the same direction, but for the y, we have the opposite direction. So in this case, I won't change delta x, I will change delta y to minus delta y. Now when the ball reaches the left wall has x position equals to 0, and the left side of our ball is x minus radius of the ball. So when this value here is less than 0, it means that the ball hit the left wall. So the ball should go in this direction, which means we are incrementing the x position and decrementing the y position. Again, the y position remains the same, but the x position has the opposite direction. So we will need to change the delta x, not delta y. So I will just say here, or the ball at x minus the ball at radius is less than 0. Then we will change delta x to minus delta x. Now when the ball reaches the bottom of the canvas, y position is canvas.height. So I will say if the ball that y plus the ball that radius, the bottom of the ball, is greater than the canvas.height, in this case the ball shouldn't go into this direction. Instead, the player will lose a life. So I'm gonna say life minus minus. We decrement the life by 1. But before, I need to create our life variable, and I will set it to 3, which means our player, when he starts the game, he has 3 lives. And then I will need to reset the ball, because the player still has lives. Again, I will put this inside the function called ball collision, and this function here will go inside our update function. Now, let's talk about the reset ball function. Let's now talk about our reset ball function. So we need to reset the x and the y position, and I will set the ball at dy to -3. If I reset delta x to 3, the ball will go into this direction. Always when we reset the ball will go into this direction, which will make our game a little bit boring. So we need our ball to go, for example, in this direction, or this one, or this one, or this one. So when we reset the ball must go in one of these directions randomly. To accomplish this, you can see that we are always decrementing the y position. That's why I set delta y to -3. But delta x, it might be positive or negative, which means our delta x will be a random number between 3 and -3. So I will say ball delta x equals 3 times method random. So this method here will return numbers between 0 and 1. I will multiply that by 2. Now this will return numbers between 0 and 2. If I subtract 1, this means that this here will return numbers between 1 and -1. If I multiply that by 3, this will get us numbers between 3 and -3. Now let's talk about the paddle and the ball collision. There's a collision between the ball and the paddle if the ball tends to enter inside our paddle, which means there is collision between the ball and the paddle if the y of the ball is greater than the paddle.y, and if the ball that y is less than the paddle.y plus the paddle.height, and also if the paddle.x here is greater than the paddle.x and the ball.x is less than the paddle.x plus the paddle.width. If this statement is true, we need to change the value of delta x and delta y of the ball, both of them, because if we change just delta y, the paddle will act like a wall, which is not what we want. Here, this is our paddle. If the ball hits this side of the paddle, it should go in this direction, which is 60 degrees from the y-axis. Instead, if it hits the other side of the paddle, it will go also in 60 degrees, but in the opposite direction. And if it hits the center of the paddle, it has to go in a vertical line, which is 0 degrees from the y-axis. So in general, the direction of the ball depends on where the ball hit our paddle. There is a relation between this angle and delta y and delta x of our ball. Let's see that here. We have here our paddle, we have here our ball. This is the y-axis and this is the x-axis. Let's say the ball is going in this direction. This is our angle A. The ball is going in this direction with a speed. Now, this means that the ball is going by the y-axis by the ball.dy and by the x-axis by delta x. Now there is a relation between the ball.y, the angle, and the ball.speed. You can see here that this is a right triangle or right angled triangle, which means that the cosinus of this angle is the ball.dy divided by the ball.speed. And also the sinus of this angle here is the ball.dy divided by the ball.speed. So from these equations here we can get the dx and dy values. So for ball.dy equals cosinus of the angle times the ball.speed. So in my code I will write matter cosinus of the angle times the ball.speed. And for the ball.dx, it is equal to the sinus of the angle times the ball.speed. So now we just need to calculate the angle. As I said before, this angle here depends on where the ball hit our paddle. So we need to check where the ball hit our paddle. This is the center of the paddle. This is the ball.x, the center of our ball, and the center of the paddle is the paddle.x plus the paddle.width divided by 2. Now, if we do the difference between the ball.x and the paddle.x plus the paddle.width divided by 2, we will get 0. Because the center of the paddle and the center of the ball has the same x position. The difference between these two values will return 0, which will get us a 0 degrees. So simple. Now let's define a new variable which is called collide_parent. I will set it equal to the ball.x minus the center of our paddle. To remind you, this is the paddle.x and this is the paddle.x plus the paddle.width. Let's see an example and calculate the collide_parent in each time. So if our ball hit the center of the paddle, the difference here is 0. But if the ball hit our paddle in the left side, the ball.x equals to the paddle.x. If we say here paddle.x minus the paddle.x plus the paddle.width divided by 2, paddle.x minus paddle.x 0 minus paddle.width divided by 2. So I will get minus paddle.width divided by 2 when the ball hits the left side of the paddle. And in this case, I will get paddle.width divided by 2. Now let's find a way to normalize these values. Instead of getting the values between minus paddle.width divided by 2 and paddle.width divided by 2, we will get numbers between minus 1 and 1. It is simple. We will just go and divide the collide_parent by the paddle.width divided by 2. Now it's easy to get these angles from these values. So I will just go and multiply these values here by 60 degrees. So minus 1 times 60 degrees, 0 times 60 degrees, and 1 times 60 degrees, which is in JavaScript math.py divided by 3. You may say minus 1 times 60 degrees will return minus 60 degrees, not 60 degrees. We will handle that soon. So now to calculate the angle, I will just say let angle equals collide_parent times 60 degrees. Let's complete our example. Let's calculate the cosinus of these values. Then for the x, we'll calculate the sinus of these values. Then we need to multiply them by the ball.speed, which we set to 3. For dy, we'll get these values: 1.5 when the ball hit the left side, 3 when the ball hit the center, and 1.5 when the ball hit the right side of the paddle. Now, dy here is a positive number, which means the ball will go to the bottom, the same here, and the same here. Now let's calculate delta x. So here we have minus 2.7, which means the ball is going to the left. 0, the ball is going nowhere by the x-axis. 2.7, the ball is going to the right by the x-axis. This will result to the ball going in this direction, and this direction, and this direction. So if you can see here, the ball is going into an opposite direction from this one here. To fix that, we need to handle the minus we talked about here. So I will just go to the ball.dy here and multiply that by minus 1. This will reverse the delta y and I will fix the problem. Like always, I will put this inside the ball paddle collision function, and this function here will go inside our update function. Final step. This is our loop function. Request animation frame to create a loop. Our draw function, our update function, we said we clear the canvas using an image. This is our draw function, and this is our update function. Inside our draw function, we will do the drawing, which is draw paddle and draw the ball. Inside our update function, we will move the paddle, move the ball, and the collision detection. Now I think you are ready to type in this part of the code. First, if you are not subscribed, please subscribe and click the bell to get notified about every new video. Let's go. So to follow the tutorial step by step, you will need to go and download the files from our repo on GitHub. You will find the link in the description. So you need to go to the repos, then choose the 2D Breakout game JavaScript. You will need to download all the files. download a zip file. When you open the zip file, you will extract the starter template files for the part 1 to your desktop, for example. So I will name this Breakout. Then I will open it using my text editor brackets. I will edit my index.html file. So I'm going to create the basic HTML file. I will give this page a title. Then I will create the canvas element with the ID Breakout. Then the width is 400 pixels. The height is 500 pixels. I will link my script files. I have here the component where I should load all the images and load the sounds. The images are the background, the level, live, the score, the sound off, and the sound on. So inside the components.js file is where we'll load our images and the sounds. So I separate them from the code in game.js to keep my code clean. So inside our game.js, it's where the code for our game lives. Now I will link first the component.js and the game.js. Now the first thing I will do is to select the canvas, and then I will get the context of the canvas. I will add here a comment. Then I will run a live preview of my project. Let's add a border to our canvas. So I'm going to say canvas.style.border. You can do this using CSS. Now I will resize my page, or to get more space on my text editor. Then I will create the paddle. So the paddle is an object. The x position is the canvas.width divided by 2 minus the paddle.width divided by 2. This way I will center my paddle in the canvas. The paddle width is 100 pixels. The y position is the canvas height minus the paddle margin bottom and minus the height of the paddle. So I will need to create this constant. The margin bottom is 50 pixels. The height is 20 pixels. Now this is the width of the paddle. And here is the height of our paddle. Then delta x is set to 5. Now I will try to draw the paddle. It's like drawing a rectangle. So I'm going to say context.fillStyle equals to this color here. And I will use the fillRect method, which takes in the paddle.x and y position, its width and its height. Then I will need to draw a stroke, so I'm going to set the stroke style to the orange color, and I will use the stroke rect, which takes in the same parameters of the fillRect method. Now let's try this on our browser. As you can see here, I get the paddle, but for the stroke here you can see that it's thin, so I will need to make it thick a little bit. So I will use here a property called line width, and I will set it to 3. If I refresh, you can see here that the border is now thick. Let's now create our function loop and use our request animation frame to create a loop. I will call my loop function just one time. Now inside we have the draw function and our update function. Let's create them. The draw function will do drawing, and inside our update function we'll leave our game logic. Let's try this. I will copy the draw paddle function inside our draw. Now you can see that we get the same result. Now inside my update function I will try to move the paddle to the top, so I will decrement my paddle.y by 30 pixels each time. So as you can see here, my paddle is leaving like a trail behind it. So to get rid of that, I will need to clear the canvas first. So I'll go inside my loop function and I will clear the canvas, but I will first need to load my background image, as we are clearing the canvas using a background image. So my background image is an image object. To load it, I will use the source property. The path or the image lives inside our image directory. I will now use the draw image method, which takes in the image itself, the x and y position. Now if I save my file and refresh, you can see now the background image. Let's now try and move the paddle by 50 pixels. Oh, that was fast. I'll use just 10. Now you can see that our paddle is moving to the top without leaving a trail. Let's now go and control our paddle. So here I will add a command, control the paddle. So I will add an event listener to my document, which is on key down. So every time the user press a key in the keyboard, it will fire up this function. Then inside I will say if the event.keycode is 37. So if the user pressed the left key, I will set the left arrow to true. And else if the key code is equal to 39, so I will set here the right arrow to true. Now I need to create these two variables. So left arrow both are variables and both are set to false. They are not pressed. Now I will just copy this. So I also need to add an event listener on key down. Then I will set this to false when it's a key down event. Now let's create the function move paddle. That will help us to move the paddle to the right or to the left. So based on the pressed key, for example, if the right arrow is pressed, we will need to move the paddle to the right by delta x. And if it's the left arrow, we need to move the paddle to the left by delta x. Let's now copy this inside our update function and let's try that. Now you can see I can move the paddle, but as I go here, the paddle goes beyond the left and the right wall. To fix that, I will need to add a condition here. So I'm going to say as long as the right side of the paddle is less than the canvas that with it, and here I will say as long as the paddle that x is greater than 0. So now you can see here that my paddle doesn't move beyond the canvas. Now let's create our ball. Okay, the ball is also an object. The ball has a radius, so I will need to create a constant called ball radius. I will set it to 3 per example. For the x position, it's just the canvas that we did divided by 2. Then the y is the paddle.y, which is constant. The paddle.y is constant, minus the ball.radius. Then the radius here, the speed is set to 4. Delta x is set to 3. And delta y is set to -3. So the ball can go to the top. Now let's draw our ball. To draw the ball, we need to create a path, which means I will use the method begin path. Then I will create an arc, which takes in the ball x and the ball y, the radius, the start angle, and the end angle, which is 360 degrees. Now I will fill the ball using these colors here. I will use the one I used for the stroke, for the paddle. Then I will use the method fill. Then for the stroke style, I will use the one I used for stroke for the paddle. Then I will use the method stroke, and at the end I need to close the path. So let's try this draw ball by copying it inside our draw function. Now you can see here the ball. So let's now move our ball. To move the ball, it's easy. We just need to change both the X position by delta X and the Y position by delta Y. I need to copy this inside the update function. Now you can see the ball is moving, but it's going beyond our wall, which means I need to add a collision detection function, which I will call ball wall collision. So I'm gonna say if the ball that X plus the ball radius, which is the right side of the ball, is greater than the canvas that with it. Here I will need to change the delta X by minus delta X. Now I will need to take this inside our update function. Let's rearrange this. Now if I refresh, you can see that there is a collision now. Now let's add the condition for when the ball hit the top wall. So I'm going to say if the top of the ball is less than 0, then we inverse our delta Y. Let's try that. Yes, so this is working. For the left wall, I will need to say or the ball dot X minus the ball dot radius, the left side of our ball, is less than 0. Then we inverse the delta X. So let's see if everything works. So you can see the right wall, the top, the left wall. And here, when the ball goes beyond the bottom wall, we need to decrement the life by 1. So the user here loses a life, and then we need to reset the ball. So let's now go and create the reset ball function. The reset ball function will just go and reset the ball that X and the Y position, and also the velocity or the delta X and delta Y. I will need to create first the life variable. I will set this to 3. So the player has 3 lives. Now let's go and refresh the page. Okay, something's wrong. Unexpected token. The line 112. Oh yeah. A semicolon. Okay. Didn't work. Oh yeah, I didn't use an equal sign here. Oh, still nothing. Oh yeah, I need to change this to the ball that the X, the Y, and X and Y. So this now should work. Now you can see that we reset the ball whenever it goes beyond the bottom wall, and also we are decrementing the life. But as you can see here, the ball is always going when we reset it to the same direction, which we will handle here. So I will need to get numbers between 3 and -3. I will copy this also to when we created the ball. So now if I refresh, you can see that the ball is going to different direction each time. Now let's add a collision detection for when the ball and the paddle collide. So I'm gonna say if the ball that x, so there is a collision if the ball tends to enter our inside our paddle. So I'm gonna say if the ball at x is less than the paddle at x, the paddle at plus the paddle at with it, and the ball at x is greater than the paddle at x, and the paddle at y is less than the paddle at y plus the paddle at height, and the ball at y is greater than the paddle at y. There is a collision. Here we need to change the ball at x, delta x, and the ball at delta y. But if we do just this, okay, I will need now to, there's a problem here. Oh yeah, I called this ball wall. I should call this ball paddle. I will need to copy this inside my update function. Now if I refresh, now you can see that my paddle is hitting the ball, but it's acting just like a wall. So let's fix that. So we need first to check where the ball hits the paddle. So I'm going to create a variable called collide bound, which is equal to the ball at x minus the center of the ball, which is the paddle at x plus the paddle at width divided by 2. Then I will need to normalize the values. So to get numbers between -1 and 1, I will need to divide the collide bound by the paddle at width divided by 2. And now I will need to calculate the angle. So the maximum angle is 60 degrees. So I will need here to multiply the collide bound by the math at pi divided by 3, which is 60 degrees. Now I will need to change the delta x by the ball that's speed times the math that's sinus of the angle, and here to minus the ball that's speed times the math that cosinus of the angle. Let's try that now. Now the ball must go to the right. That's good. And here the ball must go to the left. And here it must go in a vertical line. So that's good. This is the end of our tutorial for the part 1. There's still a part 2 where we create the bricks and show to the user the score, the levels, how many lives he has left, and everything. So see you in the next tutorial.